So hello friends, I am a G aspirant and today's my goal thermal properties of matter, and I am studying in PW Bangla batch. Okay, the topics are temperature and heat, thermal expansion, thermal stress. Okay, move to the first point, temperature. Temperature is relative measure or indication of degree of hotness or coldness of a body. Okay, the unit of temperature is Kelvin and it measured by thermometer, that we also know. How to define heat? When two bodies of different temperature are made in contact, the energy will flow from higher temperature body to lower temperature body, which is known as heat. Okay, I think heat is a kind of energy flow that flows from hot object to a cold object. The unit of heat is SI in joule and R in CGS unit. The relation between joule and arc is 1 joule equal to 10 to the power 7 arc. By the way, the other unit we used mostly that calorie, and all you know that 1 calorie equal to 4.2 joule. Move to the next page. Temperature scale are given in the diagram, that the ice point of Celsius is 0 degrees Celsius, boiling point of in Celsius scale is 100 degrees Celsius. In Fahrenheit scale, ice point is 32 degree Fahrenheit and 112 degree Fahrenheit in each boiling point of Fahrenheit scale of water. In Kelvin scale, all you know that 273 Kelvin is ice point and 373.15 Kelvin is the boiling point. It's to the next point. Move to the next point. The number of divisions on the scale. Basically, it represent the difference between boiling point and ice point. That is, in Celsius scale is 100, and in Fahrenheit scale that is 180, and in Kelvin scale that is also 100. Relation between different scale. It is the most important formula for JEE and WJ aspirants, because in the previous year questions we can see that in exam side some questions are asked um, directly asked that in this case, in that cases we can use this formula properly. To calculate the difference in scale is C minus ice point of Celsius is 0, my boiling point of Celsius scale is 100 minus 0, which is the ice point of the Celsius scale, equal to F minus 32 by 200, 12 minus 32 equal to K minus 273 divided by 373 minus 273 equal to A minus ice point divided by boiling point minus ice point. So you can see that there is a most important formula that is derived by the long formula is C by 5 equal to F minus 32 by 9. And if the examiner give that kind of question that there is there is a question that if we change um, 40 degrees centigrade in Celsius scale, then what will be the change in Fahrenheit scale? Then we can use this formula to derive the answer of the question. So, let's move to the best question in this topic is on Celsius scale the temperature of body increases by 40 degrees centigrade. The increase in temperature of Fahrenheit scale is okay. If we change in Celsius scale equal to 40 degrees Celsius, then what will be the change in Fahrenheit scale? In change in Celsius scale equal to 5 by 9 into Fahrenheit scale, change in Fahrenheit scale, and if we put the value of change in centigrade scale is 40 degree, then we can find 72 degree Fahrenheit. Okay, let's move to the next question. Yes, this is the question I told you in the previous slide that there is a direct question on this formula, that is on a temperature scale x the boiling point of water is 65 degree x is an unknown scale, okay, and the freezing point is minus 15 degree x is the unknown scale. Assume that this x scale is linear, okay, the equivalent temperature corresponding to minus 95 degree x, the unknown scale on the Fahrenheit scale would be, if we made a unknown scale relation with Fahrenheit scale, that will be this formula, that is x minus ice point divided by boiling point minus ice point equal to f minus 32 by 212 minus 32. The this is the this is the ice point and this is the boiling point. Move to the next the next topic, because this is the value putting question. If we put all the value of this given question, then we can find the exact value of the Fahrenheit scale answer. Okay, yes, this is the most important topic, thermal expansion. Let's assume that we took a metallic or metallic rod and we heat continuously the rod. Yes, there is the there is a temperature, already there is a temperature of the rod given by T1 and length of the rod is L1. If we continuously hit the rod, it will change and it will make a different length rod, that's temperature is T2, because we continuously give heat, we continuously give heat and it will and it change its length to L2. If we made the formula of change in length and change in temperature, and yes, there is the new coefficient, that is unit of that is coefficient of linear expansion. Okay, coefficient of linear expansion, linear denoted by alpha equal to L2 minus L1 by L1 the primary length of the rod into T2 minus T1. Okay, I memorized it. Okay, alpha equal to del L by L1, the primary length, the first case rod length into delta T. Okay, let's move to the next page. Yes, areal expansion. If we take a square and its primary temperature is T1, and if we heat it continuously, it will expand to a new area that is A2, and its temperature will be T2. Delta A varies delta T into A1. Okay. Let's move to the main thing, that is the for coefficient of areal expansion, that denoted by beta equal to change in area divided by the primary area into change in temperature. Okay, the next point, volume of volume or cubical expansion. If we assume a square that's length are same in every direction and its volume is V1 in the first case, and temperature is T1 in first case, it heated to V2 in it heated continuously everywhere, same amount of heat, then it changed its volume V2, and the final temperature of the object is T2. Okay, gamma, the coefficient of volume expansion. Okay, V2 minus V1 divided by V1 into delta T. Okay, relation between alpha, beta, gamma equal to 1 is to 2 is to 3 divided by if we directly make a relation between alpha, beta, gamma, then alpha equal to beta by 2 equal to gamma by 3. Okay, yes, there is a question. It is a very good question for the primary learning of thermal expansion, that there is a sphere of any kind of matter, and if we made a different sphere in the large sphere, assume that it is a different matter, or it will be or it may be hollow, then if we heat same amount in the same everywhere, then the overall what will happen, if we imagine that if we imagine that if we imagine that we continuously provide heat the large object, it will expand, and the middle sphere also expand. Okay, yes, this is the most important slide of this whole chapter, that change in time period or simple pendulum t is time period of pendulum. We know that t equal to 2 pi root under L by G. L is the length of the pendulum, if we differentiate the whole equation by using the method of error which we study in error dimension, that is delta t by t equal to half into delta L by L. And mm, if we put delta L by L from the previous slide, which slide, that is this, delta L by L, from this we can found that this formula, change in time is half into alpha delta t into t. Okay. There is two kind of case, in summer and in winter. In summer, temperature will increase, length of pendulum increases, time period will increase, clock will become slow because uh, the time period is hmm, the time period is more than the time period of pendulum clock in summer is mm, more than the normal clocks normal clocks time period. Loss of time, delta t equal to half alpha delta theta into t. In winter, temperature delta theta decreases, length of pendulum decreases, time period will increase, clock will be fast. Okay. Gain in time, because the length of the pendulum decrease, so it directly impact the time period of the original pendulum. And if we calculate that, the uh, in winter the clock is become faster than the normal pendulum, because the overall time period is less than the original time period. So what is the definition of time period? That a time period is the time mm, that the second the sticks of clock mm, complete one revolution in hot second. Okay. Let's move to the next point. Thermal stress in a rigidly fixed rod. If we fixed a rod between two walls and continuously heat the rod, then a stress will, will generated, because because the mm, because the rod wants to expand, but the walls are denied to expand, so internal stress will generated, that is equal to F by A equal to gamma alpha delta t. Then many of the students confused that where we can how we found this formula y alpha delta t. If we memorize that, if we thought that stress equal to, if we thought that Hooke's law, strain directly proportional to strain, so from the property of solids and liquid, we can find that gamma equal to stress divided by strain, and stress divided by strain, gamma alpha delta theta. Okay, let's move to the next point. Thermal expansion in liquids, real volume expansion of liquid. Okay, apparent volume expansion of liquid. Okay, plus volume expansion of a vessel, the container that the liquid contain. Okay, the coefficient of real volume expansion of liquid equal to gamma r minus equal to delta vr by vr represent the mm, real volume expansion of liquid divided by v1 the primary volume of liquid into delta T, change in temperature. Coefficient of of apparent volume expansion of liquid equal to gamma equal to delta V apparent by V1 into delta T. Okay, V1 equal to initial volume of liquid, Vr equal to real volume expansion of liquid, apparent volume expansion of liquid Va. Okay, gamma real equal to gamma apparent plus gamma vessel. Okay. Okay, let's move to the next note. Mm, the next note, yes, there is a exceptional behavior of water, that's called anomalous behavior of water. Water shows the different kind of behavior, like anomalous behavior, that if we change temperature from 0 to 4 degrees centigrade, volume will decrease, but we generally know that um, if we heat if we heat some liquid, its volume will increase, but in this case the volume is decreased and density will increase. Okay, let's move to the next point. Specific specific heat and heat capacity. Heat capacity of body is defined as the amount of heat required to raise the temperature of a given mass of a body 1 degree centigrade or 1 Kelvin. It is also called thermal capacity. Is equal to by delta T theta Ct, specific heat, amount of heat required to change the temperature of unit mass of substance by 1 degree centigrade or 1 Kelvin is called specific heat. Okay, unit mass of substance by a degree centigrade or 1 Kelvin is called specific heat. Latent heat, heat required to change the state of unit mass depends on the nature of substance and is called latent heat or substance Del Q equal to M into L. L represent the latent heat. Latent heat of fusion is the quantity of heat required to change 1 kg mass of a substance from solid to liquid state and its melting point. Latent heat of fusion for ice is 80 kilocalorie and kg. Latent heat of fusion for water LF water equal to 80 calorie per gram or 80 kilocalorie per kg. Latent heat of fusion for ice. Latent heat of vaporization, the quantity of heat required to change its 1 kg mass liquid to vapor. 540 calorie per gram for water, 80 calorie per gram for ice, and 530 536 kilocalorie per kg. Okay, let's move to the next point. Heat curve. Hmm. If we closely notice that hmm, heating is of solid melting point, the melting point melting we use the providing the latent heat, vaporization, ঠিক আছে. Principle of calorimetry. When two bodies at different temperature are mixed, higher temperature to body at lower temperature to both with the same temperature. Calorimetry.